Hi, my name is Akjol and I am full stack software engineer at John Deere, the company which builds green and yellow tractors, and I am instructor at Tentec. Let me tell you about myself shortly. I started my IT journey when I was 13, and for 20 years I am in IT field. I have 12 years of work experience, most of them for government, related to finance, encryption, and public services. And here in Tentec, I will teach you Linux lessons, also scripting lessons, and AWS. Okay, let me go to our today's topic is DevOps Roadmap. Today, I want to explain you DevOps Roadmap. DevOps is cultural and collaborative mindset that emphasize communication, collaboration, integration, and automation between development and operations in order to achieve faster and more reliable software delivery. DevOps engineers are professionals who have the skills and knowledge to work across the entire software creation and maintenance process, from development to operations, which spans the entire technology stack. As a DevOps engineer, you will not be programming the application, but as you are working closely with the development team to improve and automate tasks for them, you need to understand the concept of it, okay? How developers work and collaborate. DevOps engineers should know Agile, Jira workflows, and our second topic is computer fundamentals. DevOps engineers need to have a basic understanding of computer hardware in order to effectively deploy and manage applications. This includes understanding the different components of computers, such as the CPU, memory, storage, and networking hardware. DevOps engineers also need to understand how to configure and troubleshoot hardware. DevOps roadmap includes the computer fundamentals, and you are going to learn, if you are going to become a DevOps, you are going to learn internal hardware and how they interact with each other and how to configure them. Okay. The other important topic is operating systems. Operating systems are a crucial piece of the technology stack. The DevOps team needs to function. Operating systems not only power the local machines, but also they are run on the servers. They host the team's deployed applications. In simple terms, an operating system is a software that acts as an intermediate between a computer's hardware and the applications or programs running on it. It provides a set of essential functions and services that allows user and other software to interact with the computer hardware. Basically, this is the main thing you are going to learn for at least months or two. Okay, and you are not just going to know about the operating system, but as a DevOps engineer, you are going to be responsible to configure the operating system. Does it make sense? And there's this basic picture showing the family of Linux. Most of the operating systems in servers are based on the Linux, okay? And they are similar to each other. As such, you need to learn the command line terminal, so you are not reliant on the graphic user interface. On a server side, operating system is not like in our computers. They do not have graphical user interface, which means they do not have icons, buttons, and you cannot use your mouse to interact with the operating system in the server side. And that's why there is a command line. Basically, sometimes it's called as a CMD, which can configure your operating system on the server. Okay?
Server language, right?
Kinda, yeah, server language. It has basic commands. For example, whenever you right click and create a folder, instead of right click on the mouse and creating a folder, in Linux, we can write some commands. Like mkdir will create the folder for you. The same thing you are doing with the mouse, but you are going to do with the keyboard, okay? With the commands on keyboard. The next important topic is networking. Networking is another essential aspect of the technology stack that a DevOps team relies on. Networking enables a communication between different devices, applications, and services within the server and outside of the organization, okay? In simple terms, networking refers to the practice of connecting computers and other devices so they can communicate with each other. It's like creating a system of electronic pathways that allows information to be shared between devices, enabling them to work together and exchange the data. As a DevOps engineer, you need to understand how networking works, how to troubleshoot networking issues, how to secure network connections, and how to optimize network performance. In this picture, you can see how devices and offices are connected to each other. The basic idea is that they are connected through wires or wireless connections, but as a DevOps, you are going to configure these connections, and you have to know how to manage these connections. Scripting languages. Since you are closely working with the developers and system administrators to also automate tasks for development and operations, you will need to write scripts and small applications to automate them. For that, you will need some scripting or basic programming skills. It doesn't mean that you have to be familiar with the coding and solve big tasks. Scripting means small piece of coding. Instead of just running the command, you can write some script which will run for you. Okay? You are not going to do everything manually. Sometimes you are going to prepare your script, and these scripts may build the whole infrastructure for you. Make sense?
I've got a question.
Sure.
What's the difference between scripting and coding?
Coding includes a lot of logic and frameworks behind of the scene. Scripting is basic tasks. For example, scripting means the set of rules which should be executed. And programming means you have to decide. There are a lot of decisions, there are a lot of paths which should be considered while you are coding. But scripting is basics of the coding. Like it's comparing to calculus and simple mathematics, okay? You don't have to know the coding, but you have to know the principles, the basic principles of coding, like loops, variables, conditions, and functions. It is all about the scripting, okay? You don't have to know like inheritance, object-oriented programming, and so on. Programming or coding is more complicated. Scripting is straightforward, pretty easy. Make sense?
Yeah, thanks.
Okay. The next software is Git, version control. You write all automation logic as a code and just application code. Automation code should also be managed and hosted on a version control. And One of the most popular version control tools is Git. And nowadays, even if you are as that QA or software developer, and also as a DevOps, you have to know the Git, how to work, how to store your code, how to collaborate with your teammates using these applications, and how to share your knowledge. Because in IT, knowledge is considered as a piece of code. Your scripts are going to be piece of code. Okay? Version control is, in simple terms, is like a time machine for your files. It is a system that helps you keep track of changes to your document, code, or any other digital content. With version control, you can see how your files evolved, revert to previous state, and collaborate with others more effectively. Which means, for example, when you start your IT journey, you were writing some very simple scripts, and after 2 years, you got experience and your scripts are different, but you can also refer to your first scripts and see how you were evolving, okay? And Git software helps you for that. Public cloud providers. I hope you already heard from Serdar about the cloud. And one of the most popular cloud providers nowadays is AWS. Cloud providers are companies that offer cloud computing services, such as infrastructure as a service, or platform as a service, or software as a service. Cloud computing enables you to access computer resources on demand over the internet without having to manage them yourselves. It means instead of buying servers or buying hardware, you can purchase it from cloud providers. They will work exactly in the same way. Cloud providers are like digital landlords. They own big, powerful computers and rent out space and services on those computers over the internet. So instead of buying and maintaining your own computer system, data centers, you can just pay these providers to use theirs. It's like renting a storage unit for your digital stuff or using super fast computer without actually owning it. As a DevOps engineer, you need to understand how cloud providers work, what services they offer, how to use them efficiently and securely, and how to integrate them with your DevOps tools and processes. Any questions on cloud providers? I can dive deeper into cloud providers if you want, but this is the common sense, like.
Mr. Arnold, so as a DevOps engineer, so he has to use the cloud always, right? Or for the company. Yeah.
It depends. Like everything depends on money. How much money your company wants to spend. And sometimes it's better to purchase it from cloud, or if you have a really huge company, it is better to have your own data center. And nowadays, most of the companies, like I'm not saying that 90% of the companies are switching from a cloud to the data centers, but most of the huge companies own their data centers. Because if you purchase a lot of stuff from cloud providers, it costs a lot of money. And sometimes it's cheaper to have your own. It's like renting a car and buying a car. Sometimes it's better to rent a car if you don't know what kind of car you want. But after a while, if you're pretty sure what kind of car you have to have, like you want to have, then it's better to buy it instead of paying the rent every time, okay? Next topic, infrastructure as a code, Terraform. Infrastructure as a code is a key DevOps practice that enables you to automate and provisioning management of your infrastructure using code. Instead of manually configuring and updating servers, network storages, and other infrastructure elements, you can use a high-level descriptive language to define the desired state of your infrastructure. And this is the basic tool to make infrastructure as a code. It's called Terraform. Infrastructure as a code is like a computer magic trick. Instead of manually arranging your digital tools, you write down the steps to set everything up in a special language. When you want to perform the trick, you can use your instructions. For example, instead of manually purchasing some services from the cloud, you can write script in Terraform and it will build and purchase from cloud provider the whole infrastructure. For example, if you need 5 servers, 3 databases, and some security tools, firewalls, in Terraform, you can write one-page instructions and it will build the whole infrastructure for you. And you can also reuse it later. Make sense?
So this application is generating the code samples, right? Which you can copy and paste in your Python? Or that's
No, this is the whole independent platform. It has independent language. It is called HashiCorp language. You can write some instructions in that language which will purchase infrastructure or services from AWS, Google Cloud, any cloud providers for you. Like, just imagine you are clicking and purchasing something from Amazon every month or every day, and you can write something in the Terraform script. It will purchase it automatically for you. You will not need to go to the Amazon website and click on these items. Okay?
And does it mean that we're gonna use Terraform only for clouds when we use clouds or no?
It is one of the tools. You can use also in AWS, they have their own infrastructure as a code, which is called CloudFormation. You can use CloudFormation, but Terraform allows you to interact with all the cloud providers, not only with the AWS. And
Yeah,
if
my question is only while we work with cloud or no?
yes, exactly. Only if you are working with the cloud, then you are going to use Terraform to purchase some services from the cloud.
Got it.
Okay. Our next topic is CI/CD, continuous integration and continuous delivery. This term is used all over the IT, like developers use CI/CD, testers use CI/CD, but as a DevOps, you are going to configure this CI/CD. Continuous integration or continuous delivery is another core DevOps practice that enables you to automate the process of building, testing, and deploying software applications. CI/CD helps you deliver software faster and more frequently, while ensuring the quality and reliability. For example, when developers build their software, they are giving it to testers. And as a DevOps, you are going to automate this process. Whenever developers want to test something, they're just gonna commit their changes. They're just gonna push it into Git. And as a DevOps, you are going to configure the tool CI/CD such as a Jenkins or GitHub Actions, which will take this code, deliver it to testers, get their results, and if they are succeed, build it to the server. Okay? And that's how you interact with the developers and testers and also reports part. Okay. Continuous integration, this is a process of merging code changes from multiple developers into a shared repository. Repository means Git. And running automated tests. Nowadays, companies do not hire QAs. They hire SDETs. And SDET, software developer in testing, it is like they are automating testing process. They are writing code to automatically test the application. And continuous delivery means this is the process of delivering code changes from the repository to a different environment. Like most companies have 3 or 4 environments. The first environment is developers environment, dev environment. The second is staging, or sometimes they call it qual or cert environment. And the third one is productions. Whenever developers make changes on their code, first it is tested on the dev environments. Then it is tested on the cert and qual environment. And after all the tests passed, the new application is running on the production environment. Okay. Any questions on the CI/CD?
For continued integration and continued delivery, this is some part of the job of the DevOps engineer, right? So for this solving this to doing this job, we're gonna use specifically tools, or we're gonna write our own code for connecting all the apps and those.
No, there are special tools like Jenkins or GitHub Actions for CI and CD. These tools helps you to get the source code and to also include the automated tests in that code.
And fully automated, right? In the job.
Yes, it is.
Manual also.
But you are going to develop this script to run Jenkins or GitHub Actions. You are going to get the source from the, like you are going to automate it. You are going to specify from where to take the source, where to test it, and what should be done after test is failing or accepted. Okay? And as a DevOps, you are going to configure and develop this automation. Make sense?
And we're gonna run all the tools in the same time, right? To the run, like let's say A, B, C jobs, the projects.
Kinda, but it's not as complex as you think.
Or
You are going to work only with the Jenkins and GitHub Actions.
Mhm.
You are not going to deal with the Java and what is behind of the scenes happens. And as a DevOps culture, you have to communicate to developers, and you are going to ask the dependencies of their software. For example, if they write their application in Java, you are going to configure Java in your server. And as a developers, they are going to help you to configure it. They are going to provide you libraries or packages you have to install on the server. And it's not very complex. Okay? It's just putting pieces together in order to make everything work. Next tool is Ansible. It's a configuration management. Ansible platform that automates storage, servers, and networking. When you use Ansible to configure these components, difficult manual tasks become repeatable and less vulnerable to errors. Ansible is like having a super helpful robot for your computer task. You just say what you want, and Ansible goes to each server, making sure they all do exactly what you asked for. For example, as a DevOps, you are going to manage thousands of servers. And if you want to, for example, install one software in all the servers, you can just write an Ansible configuration, which will run on all your thousands of servers simultaneously, okay? You are not going to manually configure all your servers. You can use such tools as Ansible to do it for you. Make sense?
As one of the tools, right?
Yes, it's also one of the tools to managing the configuration. Okay, next tool is Docker.
Could you explain what's the biggest difference between Terraform and Ansible? Since they are
Okay, Terraform is to build infrastructure.
Mhm.
For example, you don't have anything and you are purchasing servers. But after you build this infrastructure, you want to update something on the servers. You want to run some scripts or install some software on those servers.
Mhm.
Terraform cannot do it.
Mm.
But Ansible can connect to each server and install some software for you.
Okay.
Okay.
Thank you.
Okay. Docker is a platform for developing, shipping, and running applications in containers. I'm pretty sure you have heard a lot of about containers. Like 21st century is becoming all about the containers. And containers are lightweight, standalone, and executable packages that are including everything needed to run in a piece of software. Docker provides a way to package and distribute applications with their dependencies in a consistent and portable manner. Just imagine Docker as an Apple Watch. You have iPhone and you have Apple Watch. Apple Watch runs some software on it. It cannot run full as a server, but it does a lot of things. The same idea with the Docker. You are cutting and putting only required things in the container. Does it make sense? It is lightweight. You don't have to purchase or run the whole server for small things. And for those kind of things, you can use Docker. Make sense?
It is some sort of the memory or storage where we can inside run our small applications.
No, it is kind of a small server.
Server.
Yeah, it's basically just imagine it's small server.
Full server, right?
Yes, it may do everything you want if you package your container correctly.
Until some terabytes, or
You can specify the limits of your container.
and also goes as subscription, right? As Amazon.
No, Docker is free,
You can put the limit on it.
but you can put limits how many resources to use. For example, Docker means you are dividing your server into small pieces. And you are saying, okay, this piece is going to be used for the database. And you are going to run Docker over there. It is dividing your server into small pieces. Instead of using one server for like big server for small things, you can divide your server into small pieces and use it separately.
As an organizer works, right?
Kinda, yeah. And other thing is Kubernetes. Since containers are popular and easy to use, many companies are running hundreds or thousands of containers on multiple servers. This means these containers need to be managed somehow. For this purpose, there are container orchestration tools. Container orchestration tools like Kubernetes automate the deployment, scaling, and managing of containerized applications. Kubernetes, like a manager for your apps, it makes sure they are always running, balances to work between different computers, and brings the new applications if needed. Make sense? Like Kubernetes is the orchestrator of those containers. You may have thousands of containers in your server, and you cannot manage them on your own. You have to use some tools. Like we heard about Ansible, which can manage the servers. And Kubernetes is kind of tool to manage those containers. Okay, as a DevOps, those are tools required to be a DevOps engineer. Any questions?
And Kubernetes doesn't work well without the Docker.
Kubernetes is orchestrating Docker containers. It cannot work without the Docker. Yes. Docker is one part of the Kubernetes.
And Docker cannot work without Kubernetes, right?
Docker can work without Kubernetes.
But
You can create a container and use it standalone container. But if you are running thousands of containers, you have to have a tool to manage these thousands of containers. You can manage them manually, or you can use tool which can manage it for you.
And Kubernetes can run all of that.
Yes.
That's cool.
And now Q&A session. You can ask any kind of questions related to DevOps Roadmap and DevOps journey.
This is the main things that the DevOps engineer should do?
Yes, basically, this is the main things DevOps engineer should do.
CI/CD, this one. And,
CI/CD, let me start from the beginning. Computer fundamentals, the hardware, Linux operating systems, how to configure the operating system, how to manage it, and use special commands. You are going to learn commands, how to interact with the operating system using command line.
we're gonna use the different operating system for working in the DevOps, or we're gonna create it. We're gonna use multiple.
We are going to, like, DevOps engineers mostly use Linux-based operating systems. Like most of the servers run Linux server. There are different families of Linux server, but they are very similar. And as a DevOps engineer, you will recognize the difference between the family of Linux. It's like they have only 2 or 3 different package managers, which differs them. And also, there are free open source or paid ones, like Debian, OpenSUSE, Fedora, Ubuntu is open source. But most of the companies want to have support, and such Red Hat Linux provides support. For example, if your DevOps are stuck on configuring Linux servers, such as Red Hat, they can open a ticket with the Red Hat, and Red Hat will give a support to it, to your engineers, okay? And most of the companies use Red Hat because it provides support.
Red Hat as an operating system, right?
Red Hat is Linux-based operating system, yes.
And that we're gonna use all those tools, right? Previous tools.
Yes.
How many of them?
Tools are...
The tools. I mean, that you show there's a few of them, right? 5 or 6, but in general.
Yeah. In general, you have to know Git. In any of the IT fields, you have to know the Git. Other things.
Also, actual.
Yep.
Sorry. Also, that was a good question actually. If you can come to the slide that you were showing all the tools in the CI/CD.
Okay.
Yeah, guys, we want to make one thing abundantly clear. All these tools, no one probably knows all of these tools how to use it. Okay, this is the thing that we want to make sure that it's clear to you that these are not the tools you will be learning while in the DevOps journey. But Akshol was showing you that these tools that you might be installing on the servers to get them ready for developers or QAs and SDETs, right? But in reality, like Akshol said, from here you will be using Git. And if you guys remember from the last lesson where I covered, there are like common tools that all of these fields use, right? And Git, Jira is basically a task tracking software. It's just a web application. There's nothing much to learn about it. Even to this day, I don't even really know, how to properly create a ticket or something like that. And Confluence is basically used like a Wikipedia for companies where they keep track of, documentation, where they explain what they did and how they did and all that stuff. But like things like a Git, maybe Jenkins and Ansible, Kubernetes, all these tools usually, if you guys remember, I said that all other fields, they will have to at least understand how they work. But in terms of DevOps, you'll be interacting a lot more with Kubernetes, Docker, Git, and some couple other tools as well, with Ansible, obviously. Does that make sense, guys? We want to make really clear that
May I
you will
ask you?
see a lot more. Yeah, you will see a lot more applications like this. That doesn't mean you will have to know all of them.
When we get live classes in your buildings, so basically we're gonna study all that stuff, and you will give us examples, like some kind
Exactly.
of tests, how it's working from scratch, right?
Yes.
Yes, and also Banu asked in the chat, actual, are we gonna learn how to use Linux OS?
Okay, we are going to not only learn how to use Linux operating system, but we are going to learn how to manage it and configure it. Linux is highly customizable. For example, in Windows machine, you can change only the background picture of your desktop. In Linux, you can change a lot of things. You can change even your My Computer icon, like My Computer. If you click on My Computer, is going to happen something very different. That's why most of the servers are running Linux, because it is highly customizable. And we are going to teach you how to use it, how to configure, manage, and customize your Linux operating system. Any other questions?
Hi, can you describe your daily task at work?
I am a full stack software engineer, and my daily tasks are full stack software engineer means you are doing everything. We are writing code, we are deploying our code, we are automating, we are using what was that? Infrastructure as a code to purchase the software and to deploy it. We are almost using every tool which you are seeing in the screen. But I am a full stack software engineer, that's why. DevOps engineers do less.
So does it mean that you don't need any help of QAs, I mean SDT developers and us?
Full stack developers, they also write JUnit tests, and sometimes they are writing Selenium tests too. That's why, like, full stack, it's very rare, it's not common to have full stack engineers in US, but some companies want still full stack engineers. But mostly software engineers are just writing the code, program or software, and write JUnit tests. That's all. The automation is done by the DevOps engineers, and tests, automated tests, are done by the SDETs.
So let's say the company has SDET developer, so all these engineers. I mean, if they have only you like as a full stack developer, do they need another another engineers to do the job, or it's gonna be just you?
One person cannot do everything. For example, companies has a lot of tasks, And if they want me to build some software, I can only build it now. Like I cannot spend time on doing like on calls and monitoring the servers. That's why you have to have a team. If someone is doing some part of your job, the other should cover you. And that's why they separated those fields. Like, okay, software engineers are responsible for developing the code. And DevOps engineers are responsible to build this code, like to build on the servers. And testers are responsible to test if something fails. Nowadays, you need everyone. It doesn't mean
Also,
that
yeah.
a full stack engineer can do everything for you.
Also, it also depends on your company as well. If they, you know, depending on the budget and how much money they would like to spend or not. It could be a startup company which might have a really small team, and they may not be able to, you know, accommodate or, you know, hiring someone just for testing. So in those situations, they might, you know, ask, or they might be looking for someone who might do all of that stuff. And there might be some positive sides. There might be, you know, negative sides to this. It depends on the person who is, you know, willing to take that, you know, job at all or not, because, you know, you might have a lot of stuff to get done, but you might get a lot of experience from doing that as well. So yeah, I think it will depend on the company. If you guys remember, I talked about my company. We have all those separate fields. DevOps, we have SDET, we have QA engineers, you know, the manual ones, and we have software developers as well. Also, we have a separate team who does the cybersecurity and monitoring and all that stuff. We also have a separate help desk who helps us. Let's say if I'm not able to install one of the application from our in-company app store, because I don't have all the permissions to be able to do whatever I want on my laptop, I usually call the help desk, and they will have all the accesses, like to be able to, you know, install some software or delete something and reinstall it for me. So it will probably depend on the company. Does that answer your question as well?
Yeah, that was a good explanation. Thank you.
Mr. Rajul, so as in general, the most of the company works with a lot of different methodologies, right? As agile, as a waterfalls, or the sort of. And DevOps is one of the methodologies, or the DevOps
No.
into the one of the methodologies?
Nowadays, most of the companies are using Agile. It was back like 10 years ago that waterfall was popular, but nowadays everything is Agile. And DevOps is not a methodology of how things running. DevOps is part of the team, of the deployment team. For example, you have a software engineers. DevOps can also run on the waterfall model or in Agile, it doesn't matter. But this is part of the team. Culture is different, DevOps culture is different, but methodology is the same.
But Agile can work without the DevOps engineer, right? So DevOps engineer literally like upgrading or boosting their work.
Yes.
So,
DevOps is boosting the process, because if you don't have DevOps in your company, someone should deploy it, and it may take some time. They are going to deploy it manually or somehow. Or sometimes system reliability engineer deploys, but it is manual deployment. And what DevOps does is automating this deployment. It's boosting, yes, your deployment is going to be faster and without errors, because everything manual means you may have some human errors. Human always make mistakes. But if you automate it, there are less mistakes in automation, okay? And DevOps are automating this interaction. DevOps is automating this cycle, infinite cycle.
between the workers, right?
Yeah. Any other questions?
May I ask a question? Just in general, because I see that slide. For me, it's like, you know, when you're going to some auto salon and you see so many different kind of models, and you see like different kind of cars. And for me, I already get that explanation. But from my previous experience, from my previous jobs, I want to ask you another question. Basically, when you're going to some job and you know basic knowledge, and then my question is, you again, or you still need to learn some additional stuff, depends from company, or you already know, we already get some more than enough knowledge to just to get in that process, or we still need to learn something inside company, because it depends from how they operate, how they're doing different stuff, or from structure inside.
Yes, let me answer to your questions. Basically, there are millions of tools similar to each other, and every company, depending on their budget, purchase different kind of tool set. They are not purchasing similar tools for every, like not every company use same tools. And in IT field, whenever you are onboarding, every company teaches you their stuff. How do they work? Even agile is very different from company to company. Some companies prefer like 2-week sprints, some companies prefer 1-month sprint, and so on. Like it depends on the company. And not every company use Jira. There are some other tools like Raleigh and so on. They're going to teach you. But the most important thing that you have to understand the concept, how it works, the logically, what happens behind of the scene. It is not important what kind of logo is standing on your tool or what kind of language is your tool using. But the most important is to understand how it works and what should it do. And if you understand the concept, even during the interview, they are going to ask questions related to concept. They are not going to ask you, okay, we are using Datadog and explain me how Datadog works. They're going to ask you more general questions. Okay, how do you collect your logs? How do you monitor your servers? What tools do you know? Because tools are similar to each other. And that's why you have to understand the concept. Okay? And if you know the concept, you can prove your knowledge on the concept, and they're going to teach their tool, which is going to be very similar to the tool you already learned. Does it answer your
Also,
question?
Thank you.
Yes, go ahead, Serdar.
yeah, I would like to add as well. So maybe I'm not sure. Maybe you're interested in these icons or applications that we're talking about here that you see on the screen. I can tell you one thing. So from technical perspective, there are some tools that it's really like slim to none chance to change, right? Like Linux. Once you learn Linux, there's no way other companies will be using something else instead of Linux, unless you go to some company who specifically uses Microsoft servers, right? Microsoft Windows Server, which is like, if you guys remember, we talked about it, 95 or 97% of the servers in the world are running on Linux. So once you learn Linux, you have that in pocket, right? There's a really small chance that that thing is changing. Then Kubernetes, Docker, they're not changing anytime soon, right? Git, it's not changing anytime soon. So already we've talked about the 4 tools: Linux, Git, Kubernetes, and what is it, Docker. Okay, there are some things that are coming up. If you guys remember, we talked about the trend versus the hype. There are some alternatives that are coming out for Docker. I think they call it, I even forgot the name. I think it is coming from a Red Hat company. But right now, not many companies are using. So We're not sure if it's going to replace the Docker at all or not, but the idea is the same. It's still the same, like a containerization technology as Docker, but it does things differently. So what can change? Let's say you went to this DevOps Bootcamp and you have studied. Let's say we explained you about, let's say, Jira or something like that, right? And like Akjol mentioned about the sprints, it could be 2 weeks from company to company. It could be maybe 1 month. But the other tools, they're not going to change no matter which company you go, right? But the processes might change, meaning maybe they're not using Confluence to document whatever they're doing. Maybe they're not using Jira. Maybe they're using some other tools. Like if you think about it, this Confluence and Jira, you don't even have to worry about these tools. So I can probably explain it to you and show it to you like in less than an hour, these both tools. There's not much to worry about. All you need to worry about to get technically real well. All those tools that I just mentioned, Linux, Git, Docker, Kubernetes, and what else did I mention? I all forget, but that's the main idea. And if you guys remember, we talked about the shopping periods during the Black Friday and all that stuff. If you remember, I also mentioned whenever whenever with the tech, there's a high volume, there's a lot of users are trying to shop. If you guys remember, I said it will automatically spin up a lot more copies of your service. Do you guys remember? All that stuff is being done by this Kubernetes. This is the orchestration tool, right? The moment it detects there's something a lot of people are trying to access to your website, it will spin up more containers. And the moment that volume decreases, let's say it's all people already shopped and the traffic is slowing down, it will basically destroy all those extra containers that it created. And all you got to do from the DevOps perspective, you basically in the text file, you say that, you know what, if there's let's say if there's a lot of users, detected, scale it up and create, let's say 50 containers, basically 50 copies of your application. And whenever it detects that it's slowing down, okay, you say, you know what, at minimum, run 2 copies of my application. And it will automatically do that for you. If we didn't have these kind of tools, someone has to sit in front of a computer and manage it manually, one by one. Does that make sense, guys? Does the example make sense or? Okay.
Yes, yeah, thank you.
Ruslan
Yeah.
asked a question about when we are going to put our hands on all these tools. Like bootcamps, or in our case, we are providing 2 lessons of lections where you learn and 2 lessons for hands-on. You are going to make your hands dirty. You are going to work on it. And we have projects on every specific tool where you have to do it on your own. Which means
maybe
you will have enough practice on those tools.
And we're not sure, Ruslan, maybe he asked if we are going to be working on those tools in this free course. Maybe that was a question, I'm not sure, but
yeah, that was the question actually. When are we going to try actual when we're going to try actual
so so
all these tools actually on real time?
So these courses, these free lessons, which is 8 info sessions, these are the main purpose of this to give you a clear understanding of each field in this IT industry, so that you guys can make a well-informed decision, right? So that we want to make sure you are understanding what DevOps is, what SDET does, or software engineer does. So in these free courses, we will not be doing any hands-on, but these are this is the great opportunity for you guys to actually ask questions. That's why we put Betul and Julia, so that you can guys ask them their experiences when they were switching basically the industries. I think both of them were working in some other fields, not in IT basically. So this is the main purpose of this free courses. But if you sign up for our DevOps Bootcamp, we are starting on February 6th. And yeah, when we start on February 6th, that's when we will be diving into Linux, starting with Linux. Then we'll switch to scripting, Python, Terraform, and all Ansible and all that stuff. The last one is
So
the
basically, I will be on a actual boot camp, right?
Yes.
What is it? Yeah.
Basically, you will see and
Okay, yeah.
put your
All right.
hands
Thank you
on.
for the clarification. Appreciate it.
Yep.
Any other questions?
Can I ask? Hello.
Yes.
I have a question. In your opinion, how do you think what kind of the tools will be harder for new students to manage it?
I think the hardest tools are going to be Linux and scripting. Others are software tools you are going to use, like they're Linux, you are just going to run commands. Less interaction, black screen. As a full IT engineer, you are going to work on a black screen the whole time. And this is gonna be the hardest part. But after Linux, everything is going to be more interactive and easy.
Okay.
And
Also-
also, guys, when we say all of these tools, Kubernetes and all that stuff, we're not deep diving into it, but all these tools are running somewhere, right? They must be running somewhere because you are giving them text file, and given your text file, they do what you ask them to do. So all these tools are already running in a Linux machines. Okay. It's a it's not important. I didn't want to go into deep
Also-
dive into it, but
Yeah.
that's what actually happening.
Okay.
Go ahead, Azada.
Yes. Also, I have questions about languages. I know we will learn Python. What else? First question. And next, and what a big mistake DevOps engineer can make. And he will be held responsible for that at work.
Okay. First, your first question. We are going to learn Bash scripting language, which is one of the main scripting languages in Linux operating system, and we are going to learn Python. These two languages are main one, but we are also going to learn some file format types like as a JSON, XML, and some HashiCorp language related to Terraform. Like three languages. And second question, what is the biggest mistake can DevOps engineer do? Nowadays, companies do not allow you to do big mistakes because you are going to have a team and you are not going to be responsible on your own. Do not be afraid that, okay, if I made the mistake, then it may bankrupt the whole company. No, you are not going to be the only one who is doing some stuff on the company. And team is going to decide and they are going to communicate. You are not going to be the only one who is responsible. And there are no like big punishments for the IT engineers that, okay, if the DevOps team made a big mistake, they are not going to charge and take your house and everything. It's not kind of that job, okay? You are not going to be, for example, there are two ways, like if you are selling some company code stuff, then you are going to be responsible. This is the hugest mistake you may do if you are selling some data from your company. Others are not big mistakes, okay? Let's consider in that way. Selling company data is going to be a crime. Others can be like mistakes.
Okay, I see. Thank you.
Ms. Radel? So as I understand, not all company can afford the DevOps services, right? And as a DevOps engineer, can you, by yourself or with your team, install from the beginning the DevOps engineer services to the agile company, let's say?
Yes, this is a good question.
How long it takes, and you guys gonna teach us that, or you guys gonna teach only the how to work or installing also? Because I've heard this takes a long time.
Okay, this is a good question. Nowadays, some companies they don't have DevOps culture and at all. And they want to hire someone to automate their stuff. And in the bootcamp, we are going to teach you how to start building infrastructure and everything from scratch. It doesn't mean you are going to see already created ones. You are going to create everything on your own. You are going to build your own infrastructure on your own AWS account from scratch. The same thing you can do for the company you are hired for. Okay? You can later automate a company which hasn't had before like DevOps engineers at all. You can implement the DevOps culture in the company from scratch too.
As a company, right?
Yes.
Excellent. That's some sort of the next level, right? Once you get developing your own.
Yes,
company.
because if the company doesn't have the DevOps engineer at all and they are starting DevOps, then they are going to hire DevOps engineer, like senior DevOps engineer with a lot of experience. Because he's going to build everything. He's going to transfer from simple cloud storage to the infrastructure as a code. He's going to implement Terraform and everything from scratch. He's going to build the CI/CD pipelines and so on.
And DevOps engineer is only in the market who helping the companies to boosting their jobs, or there's beside of it?
Like DevOps is a culture. Previously, this task was separated within software developers and system reliability engineers, and they had like a lot of conflicts with each other. And there comes DevOps and fix everything. DevOps is the intermediate between developers, system reliability engineers, system administrators. And nowadays, companies do not need any more system reliability engineers or system administrators because DevOps can do their job. Kinda. If you are a good DevOps engineer, then you can be hired as a system reliability engineer, system administrator, Linux administrator, or automation engineer or cloud engineer. Any of these positions are available for the DevOps engineers.
So basically, he's like as a project manager, but more into the right for each department.
It's kind of technical project engineer, yes, because DevOps engineers are familiar with most of the tools and can cover or back up a lot of positions in the company, IT positions. There is another question. Do DevOps engineer need pass some professional certifications?
Okay. So my take on this, I think you don't need any certification. Also, I mentioned about that I have my Linux certification. Certificates usually last from 2 to 5 years. So every 2.5 years, you should be updating. You have to retake the exams and get recertified. Most of the companies, I don't think they some of them, I think most of them, they don't care about all of that stuff. They know that they can pass it, or someone else usually does. I've even heard that some people will pass it for you. So I personally think it doesn't do much. But our students there are some, and most of them are They are getting their AWS certificates, let's say Kubernetes certificates, Terraform certificates. Yeah, it doesn't hurt, right? So if you can get it, it's awesome. So maybe it's gonna help you. Maybe it might help you when, you know, let's say if you were an HR and you had, let's say, 100 applicants. So you will not be able to, you know, interview all of them. So you have to maybe filter out somehow. So you might say, you know what, show me only the ones that have a certificate, some sort of a certificate or something like that. Maybe in those situations it might help, but I don't think it's really crucial to have a certificate. Actual,
Yes, but there are some certificates like AWS certificates you may take, professional certificates, Terraform, Kubernetes. And as a bootcamp, we are providing some week offs to prepare for this kind of certificates. We are teaching everything and then preparing for the certificate. You will have some time to take this certificate, like to pass exam for this certificate. Not always. Baktaguz says that it looks good on resume. On resume, I don't have like I have project management certificate and so on, but nobody cares.
yeah, it like I said, like Bakhtigur also mentioned, so it might look on resume, but it might be better when you know, they're filtering you out. It might look good from the perspective of HR, but from the technical perspective, they're probably going to ask you, you know, when you are actually interviewing with the manager who you will be working for, technical manager, or the team that is getting interview, they will ask you actual questions. So even if you say, you know what, I have my certificate, they're not gonna tell you that, oh, that's fine. Okay, if you have a certificate, that's good. You pass, right? But they will not do it most of the time.
Like for the interview, certificate doesn't mean anything. They are going to ask you technical questions anyway. Any other questions, guys?
And also, while studying DevOps here, you will have time. So it might be a good idea actually to get at least one certificate. Okay, because you're already studying and you will have time specifically
Which one?
for that. Well,
I want to ask which one will be more valuable.
So I think any AWS and Kubernetes certificates might be valuable, right, Akshal?
AWS has also different types of certificates.
That's true. There are a lot of them actually.
Solution architect on AWS is going to be better. Like when the technical interview comes, I was interviewing a lot of people and we never looked at the certificates. If people had a certificate, we would ask more complicated questions because we already know, okay, this man has a certificate, then I can ask harder questions. Sometimes it depends from company to company. But if your technical knowledge is good enough, then you don't need any certificate.
I have a quick question.
Yep.
So let's say we're done the boot camp, everything is fine. I mean, we're about to jump into the market. So is there any like a specific things that we have to do before we go to the market? Or we have to build our resumes first? Or will any of you guys going to help build that resume for us in order to jump before
Yes.
that we jump into the market to seek the job?
Yes, in our bootcamp, when you are completing with the technical stuff and while you are preparing to the market, we do have lessons called soft skills, which will prepare you for the resume preparation, interview preparation classes, and also the how the company runs things. For example, Jira stuff, Confluence stuff. This is not technical, but more soft skills. And you are going to have soft skill lessons.
Okay, that's how it works, right?
Yes.
So before we go, we'll have those classes where we're gonna learn what to say,
What to
and
say,
what
how to say,
and
when
all
to say.
that and all that good stuff, right? So you will prepare us to be ready
Yes.
and look professionally over there.
Yes.
Yes, exactly. In those soft skills classes, one of our instructors, Jazira, she walked you through how to respond to emails, how to look more professional, how to, interact with your colleagues and all that stuff.
Okay, that clear. Thank you very much, guys.
Yep.
Good answer. Thank you.
Hey, I have a couple questions. I just joined the Zoom meeting, but yeah, you might have already answered these questions, but still curious, how the lessons are going to be. I mean, the structure, is it going to be the theory and then the practice hands-on projects? I know there are 4 hands-on projects at the end of the course, but for example, the first session, how would that start? Would it be just the theory and then the practice right away, or is going to be just interactive lessons? Like, yeah, just curious. Sorry, you might already answer this question, but still, like, want to ask you.
No, that's a great question, actually. So, in my lessons, so basically Linux, we conduct Linux lessons, me and with Akshol. I come in for 2 lectures in a week where we cover where we actually learn the Linux, how it's built, how it actually runs, what's the command, how to run those commands, and when you run a command, what actually happens. All that stuff you learn with me. With Akshol, you do hands-on and the homeworks, right? So it's 4 days a week. But even with me, it's not like I'm opening up some PDF and reading you through the document, right? We are actually in the Linux box. We open up a terminal. If you guys remember, I showed you in the last lesson, like a black screen terminal. We open up, and whenever we let's say we covered some commands, we actually try those on the on those Linux boxes instead of me showing you some PDF presentations. Okay, I personally don't like doing it that way. That's why I straight jump into the terminals. But having said that, there are some classes where I actually need to show you some visual stuff, like a picture or something like that, to be able to convey the message or the thing that I'm trying to explain. Because all of these things are abstract, right? There's nothing physical that I can show you. Here you go. This is the thing. So in those rare cases, I will probably open up some picture or something like that. But even to this day, I don't really have any presentation. Even if I have a presentation, it might be like a bullet points to remind myself what topics I was going to cover for that lesson. But no theory like in universities where professor might just scan or copy page from the book and put it on the slide. Nothing like that.
Right. Yeah, I
Yeah.
think that answers my question. Yeah, I think because it gets boring, one person just reading from the notes and the others trying to understand, and it's just, yeah, you just want to sleep, right? But when
Exactly.
people, get engaged, into the terminal or the commands and they can actually try them themselves, that's, I think, more interesting.
Exactly. And but having said that, this doesn't mean we have somewhere you can go ahead and read up on it, right? So obviously we have our curriculum content. Whenever I conduct lessons, I tell the students, let's say you have to come to lesson by reading, let's say lesson 3. Let's say today was a lesson 2, and I asked them to read upfront lesson 3. No matter you understand or not, it doesn't matter. So I want you to go ahead and try to read it and understand it. Do a little bit research.
Right.
But when you come back to lesson 3, we are going to actually cover that whatever you saw in our content or curriculum.
Mm-hmm. Right.
That way, it's a lot easier because you might have understand even if you understand when you are reading on your own, like let's say 20% or 25%, at least you will come into the lesson by hearing some words or jargons, and you will have better questions to ask, as opposed to if you come to lesson we have no idea what to ask, because this will be the topic you have never seen, and I'm going to explain it to you. You will most likely understand it, but you won't know what you actually didn't understand, so you may not have better questions to ask.
Mm-hmm.
Does that make sense? But
Yeah.
yeah.
Sure.
So in brief, it's a 2-day lecture and 2-day hands-on and a homework thing, so 4 days a week.
Yeah, so is it for each topic, or it depends on the topic? Like for example, for Linux, you said, is it, sorry, how long is it gonna take to go over the Linux?
So Linux, I think months or months and a half, right, actual?
Yes,
About
months.
6 weeks or something like that, yeah.
Okay, so 2 days of the learning and then 2 days of the projects, right? For Linux
Practice.
first.
Yes, practice.
Oh, practice, sorry.
Practice, yeah.
Projects are
Practice.
different. We are going to have projects for every tool. Like Linux, we are going to have
Right.
Linux project. For AWS, we are going to have an AWS project. For scripting, we are going to have scripting project. And we also have final project, which includes everything you learned within the bootcamp and some stuff you haven't learned, but you have understanding on that. Final project is the hugest project. Like it contains almost 2,000 lines of code and so on. Like
Right.
Yep.
and
So
contains the whole infrastructure.
exactly. But every week you have for practice you have questions, you have homeworks and all that stuff that you need to actually get your hands dirty and try it out yourself. And to be able to finish, let's say, the project for Linux, you need to learn all that stuff that we have covered until that project. Otherwise, you won't be able to do it, or you won't understand what's going on.
And by the way, the lessons depends on the previous one. You couldn't skip the lessons. For example, you cannot skip the Linux and start with the scripting. You cannot skip the scripting and start then other Terraform lessons. They are depending on each other. They are built on top of each other. Okay, that's why it's important to attend to every lesson. You cannot skip even one lesson.
Right.
Yeah, all the tools that we just talked about, they all run on Linux. So whenever you say to Kubernetes or let's say Ansible, you know what, update this server, or on this server, let's say update this Chrome browser or your database. All those, when you say update, there must be some sort of a command, some sort of a command has to be run to be, to update your software. So they're all at the very end, they all go to Linux because they're all running on Linux, okay? It doesn't matter Kubernetes or whatever. They're like Linux is a fundamental. To all
Right.
of
So
this.
yeah, the server itself is going to be hosted on Linux, right? So every command that we run, it's going to be Linux commands, right?
Yeah, servers will be running on Linux.
Right,
Linux
servers on
operating
Linux.
system will be running on those servers. Yeah. So
Right.
like you are running your Microsoft Windows operating system or the Mac OS or whatever on those servers, Linux is the operating system that is running.
Right. And yeah, sorry, I may jump from one topic to another, but you might already covered these questions, but are we going to be taught all these tools that are on the CI/CD pipeline?
Okay, yes. Yes, meaning we actually covered this question. We actually made it clear that all these tools that you're seeing here, this
Right.
doesn't mean DevOps has to know all of this. So
Oh,
this
okay.
Maven, yeah, Maven is for Java developers and whatever. SE
Mhm.
that you see, it's a Selenium JUnit. This is Java as
For
well. Selenium
QA.
is the
Yep.
yeah, Selenium is the SDET developers, SDET testers that they use
Mhm.
to test your application with. So this has nothing to do with DevOps, okay?
Right.
From this picture, all you have to know with, and by the way, I also mentioned all other fields will have to know or understand at least, like Git, Docker, Ansible, Kubernetes. These are the
Mhm.
tools, maybe Jenkins as well. These are the tools usually DevOps they know, they understand, or they have worked with. All
Mhm.
these other tools is basically you as a DevOps engineer, because you manage the servers, Linux servers, you are
Mhm.
asked to install all of these. This doesn't mean you have to know them. Like if I were to ask you, you know what, can you install a Zoom application for me on my laptop or Chrome browser, right?
Mhm.
You don't actually have to know how Zoom works or whatever. You can just Google and download the Zoom or Chrome browser. You will install it for me. That's it.
Mhm.
Okay, that doesn't mean you have to understand all of this. But that's a good question. We reiterated and made sure that this doesn't mean you have to know all of this.
Mhm.
Okay.
One thing DevOps engineers should know is how to configure these tools. Whenever you are installing some software, it has a documentation, the configuration properties. For example, the default username or default folder where it should be installed and so on. DevOps engineers should configure them. And most of the configurations are written in a XML or JSON file.
Mhm.
And as a DevOps engineer should go to the documentation, find that part which arranges the IP address or usernames and has to configure it on the software which was installed. Like you don't have to know the software itself, but you may have to know the configuration, how to configure it. And configuration basically almost done in one file, most of the configurations. And they have pretty good documentations. And we are going to teach you how to read this documentation and find the exactly right way to configure. Okay.
Right.
We are going to configure a lot of software and we are going to provide you some simple documentations and you are going to follow and it will help you to understand how the configuration files work. And it doesn't matter if the software, you have never seen this software, but configuration is going to be similar to others.
You guys also mentioned, I think, yeah, I think Serdar mentioned about the curriculum, right? So are we going to be provided with some kind of ebook that will have all the commands, Linux commands, you know, the book that we could memorize from the commands? I don't know, like, or shall we take the notes every lesson? Like, how it's gonna be?
Anshul, you want to go? Okay.
I want to just
Go ahead.
I want to just say that our Confluence contains most used commands already. You are going to be provided a Confluence, which has details about your lessons, what you are going to learn. But on the other hand, we are also providing some books, which may be your handbook. For example, Linux handbooks and so on. We are going to give you some details about those books. And also you are going to have a curriculum where you can refer. But anyway, we highly suggest our students to take notes because whenever the note is written by yourself, you are going to memorize it better.
Yeah, that's true. I agree.
Yes, Serdar?
Yeah, like Anshul said, it will differ from student to another student, right? Some people are visual learners, some people learn just from listening, like never taking notes. So it will depend. So student has to know their, best way of learning. So if you think you will benefit by taking notes, you can do that. But I've seen people who don't like. Personally, I've never taken notes at all in my university or college or whatever, right? So I'm a person, I have to listen while, you know, 'cause I probably the issue is that I can multitask. Maybe that's the issue. I can listen and take notes. Maybe that's the reason. But that's how I do. You see, maybe Dawlet, right?
Yeah, yeah.
Yeah, maybe you can, while you are, you know, listening, you can take notes. Maybe it works for you. So everyone is different, but I definitely suggest Linux books, and we can always share. There are tons of resources about this Linux, and there are some cheat sheets. That's I think that's what you were referring to. It's like a one page or most used commands and stuff like that. There are lots of them actually. We can almost always find and, you know, and share those information. But there are so many commands in Linux. Does that doesn't mean you have to know all of them. Even I don't know all of them. But once we learn how to use the command and how to read its documentation, right? You will be able to go online, search it, and you will be able to, you know, read its documentation, and you should be able to use them, or you will be doing a lot of searches as well, because there are some commands that are really complicated, and they have a lot of options that does X, Y, Z, or whatever, right? If you put, let's say, if you enable some option, it will do X. If you provide some other option, it will do Z or whatever. So it's impossible to remember all of those. So that's why we always, you know, look it up to manual page of that command, or we will just do Google search, which explains it, how to use it, and what it does. The important thing to understand is that there will be some commands that will become a second nature to you. Like you are using your mouse and copying some file from one folder to another. There are some commands in Linux that will become as a second nature. So you will never, you know, think about those. You will automatically be typing all those commands because you use them a lot during the day, during your career. And some commands you will need from time to time. So it is okay to, you know, not to remember how to use it, but it is important to remember that, oh, you know what, there was some command, but I don't remember how to use it, but I can always look it up how to use it. That's the most important part. So we don't memorize stuff, okay?
Right. Yeah, yeah. I actually work as a DevOps engineer right now, but I have a couple friends right here in the Zoom chat, so I'm trying just to guide them through and just provide them the better DevOps journey. I mean,
That's
make
great.
it.
You probably know that you don't
Yeah,
remember all of
for
those commands.
nah, for sure, yeah. But I mean, your fingers remember the commands that you run every day, but you don't need to
Exactly,
memorize
yeah.
the whole thing. Yeah, that's true. Yeah, just yeah, you guys rock. I think
Thank you for guiding your
yeah.
friends as well. These info sessions are, you know, exactly for those. We want people actually understand what field they want to go into. We want to make sure so that you can guys make a, you know, well-informed decision, okay?
Yeah, that's true. There's so many IT schools, and it's very hard to make decision which one is the right for them.
Exactly.
Because it also depends on the person,
It's not
right?
easy.
No, before
Yeah.
the IT schools, you have to make a, like you have to choose between the IT fields. Like, are you willing to study SDAT? Are you willing to study QA, or are you willing to study software developer, like front-end software developer? Like, that's why we are explaining different fields, IT fields. And DevOps is one of the fields. And
Yeah.
if you like this kind of field, then you are welcome to study in this field. Otherwise, you can select, like we are also explaining about SDAT, about software engineering. Software engineering, I think personally, the hardest one. If you are going to be a software engineer, you have to know a lot of things. You have to understand the theory, the IT, you have to understand the math, calculus, like theory of permutation, probability, and so on. Like, and those fields like SDET and DevOps, you don't need this. And that's why we
Personally, yeah.
explaining to students, like to newcomers in IT field, that there are different fields and you may select. And I highly do not suggest to become a software engineer or software developer.
Yeah, I think just advice to other guys, newcomers who is coming to IT field. I think DevOps is just the perfect place for people who don't have IT background. But at the same time, DevOps is not an entry position, but you could still learn so many things on the fly if you're a hardworking, person. So I really like DevOps engineer, to be honest. And yeah, and that's why I'm bringing my friends to DevOps field as well, because I feel like DevOps is the right place for them to to get into IT.
Yeah, and like we said on Thursday, Better will be going over, all the fields that are within side of the DevOps. So if you study DevOps or whatever, there are so many like other fields which is inside of the DevOps, and there are actually quite a lot. You will see it on Thursday. She will be talking about all of those, like cloud engineers, site reliability engineer,
Oh, right.
system
Inside
admins, and
DevOps
all that
engineers.
stuff. Yeah, once you study that, you can apply to any of those positions. Actually, Akjol mentioned earlier as well.
Right.
Yeah, it depends on what you are, trying to do, or what you like and stuff like that. In Estet, we already mentioned in the first day, I believe, in Estet, you are expected to write some Java code. I'm saying Java because most of the boot camps, they teach you Selenium, and it's Java based. So I have not seen any boot camps. Maybe I'm not aware where they're teaching you Estet to become the Estet, and they're not teaching you Java. So most of them, most of the companies are, it's probably Java. That's why. So if you're okay with that, maybe Estet is a right field for you. If you're okay with writing Java code or coding most of the time.
Yeah. But it also depends on the market as well.
Yeah.
I think market is in a big dip right now. It's very slow right now, and as that's our companies are not hiring as that's right now.
I think companies not hiring QAs.
QAs, yeah, QAs.
As that
Yeah, QAs are manual
kind of
testers.
complicated QA, but
Yeah, as that is more automation, right?
yes, as that is
Yes.
automated testing.
And by the way, do you guys have any other questions? Dawlet, do you have any other question?
Let me look at my
Thank you, by the
notes.
way. These were really great questions, and we're
Yeah,
keeping these sessions really interactive. I really appreciate you guys. Because we have one more question in the meeting chat, if you don't have any.
No, I don't. Please go ahead.
Okay, thanks. Akshal, do you want to take it? Aizada is asking, will Tentec be providing with real project that can indicate in the resume?
Yes, as I said, in our every lesson, like in our every topic, big topics, we do have projects, which are real world projects. And by the way, we have the final project, which is very huge, and you can show it in your resume as a project. It will contain all the automation tools. It will contain the Terraform, CI/CD. Also, it will contain Kubernetes, Helm chart, and Datadog. Everything in one project. And you are going to have this project for 3 weeks, I think.
2 weeks. So
2 weeks.
final project is like 2 weeks. 6 lessons in total. So when we say 6 lessons in total, if you multiply it by 3 hours each, so 18 to 20 hours only, final project. Which is at the very end. We're talking about the final project when you are done with the whole DevOps roadmap. Does that answer your question, Azada? I'm not yeah, she's still here. Okay.
Yes.
Any other questions, guys?
If there is no question, Serdar, we can close the session.
Yeah, we can wrap it up. Thank you guys for joining. This one was really great as well. We really appreciate that. You guys are keeping interactivity. Otherwise, it gets really boring. I'm pretty sure Akshol had a great time as well.
Yes, sure. Okay, guys, have a good one.
Thank you, guys. On Thursday, as usual, we will post. We will be keeping you up to date. We will send the notification in the chat a day before and the same day an hour before, so that you guys just in case if you forget. So the next one is on Thursday, and it will be with Betul. Okay. See you guys.
Yeah,
have
bye.
a great evening.
Thank you.
Yep.
Thank
Thank
you.
you.
Thank you.